in this case, which is y. Now we're solving for x. So we square root both sides, and 0 is equal to x. And so our x-intercept is 0, 0. Now, these happen to be the same because it's the parent function. And if you remember that, parent function intercepts right there at the origin. Now, that's a very flat function, but just for sake of example. So this function here passes through the x-axis and the y-axis at 0, 0. So it happens to be the y-intercept and the zeros of the function all in one. Now, as you get into different functions, you're going to see that the x and y-intercepts are different for those particular problems. For example, let's get into some practice. And you had 1 through 6 and then 11 and 12. So we're going to do 1, 3, and 5, and then we're going to do both 11 and 12 and potentially come back to 6 to look at something real quick. So 1 through 6. Number 1, the directions say find the y-intercept. So let's write our function down. F of x is equal to 1/4 x squared. Well, for the y-intercept, we plug in 0 for x. So f of 0 is equal to 1/4 times 0 squared. When I do so, 0 squared is 0. 0 times 1/4 is 0. So f of 0 is equal to 0. And that's not our answer. Our answer is the y-intercept itself, which is 0, 0. Then we go on to number 3. F of x is equal to 3x squared minus 5. Again, plugging in 0 for x. F of 0 is equal to 3 times 0 squared minus 5. So when we solve here, 0 squared is 0. 0 times 3 is 0. 0 minus 5 is negative 5. So when we plug in 0 for x, we get a negative 5 for y. And that's our y-intercept. Number 5. F of x is equal to 3x squared minus 2x plus 1. Again, plugging in 0 for x. So 3 times 0 squared minus 2 times 0 plus 1. 0 squared is 0. 0 times 3 is 0. 0 times 2 is 0. 0 times negative 2 is 0. 0 minus 0 plus 1 leaves us with 1. And our y-intercept for number 5 is 0, 1. And then that's all that we're going to do for those odds for just this second. Let's go to number 11 and look at the zeros of a function. And they ask us to find them algebraically rather than graphing. So we could find these graphing, but that takes longer, and we're not going to do it this way for these problems. So f of x for number 11 is equal to x squared minus 2x minus 8. Now, algebraically, how do we find the zeros of a function algebraically? Well, this is where we go back to 12.3, 4, 5, and 6. Maybe even before then, where we're looking for the value of x of this quadratic right here. So essentially, this is what we're doing. Let me pull this back real quick just to remind us. We're solving for the x-intercept, or the zeros. We do so by plugging in 0 for y. Well, what is y in this function? It is f of x. So we're going to plug in 0 for f of x, and we get 0 is equal to x squared minus 2x minus 8. Well, this is something that we've seen in the past. Like I was saying, we've solved this by factoring, taking the root, quadratic formula, or completing the square. And so again, here's where we have to come into this problem thinking about what's the best way to solve it, the most efficient, the fastest, the best. Well, we're going to try factoring first because that is the fastest. Then if that won't work, we'll go to taking the root. If that won't work, then we'll go to the quadratic formula. X squared minus 2x minus 8. Remember, if we're going to try factoring, we have to separate 8 into factors. And we like to choose the factors that are the two closest together. So we're going to go with 4 and 2. Well, 8 is negative, so it either has to be negative 4 times 2, or negative 2 times 4. So again, negative 2 times 4 or negative 4 times 2. Those are our options for those sets of factors. Now, will either one of these give you that middle term? So what's negative 2 plus 4? Well, that is positive 2. Is that the same? No. So that won't work. What about negative 4 plus 2? Well, that gives us a negative 2. Is that the same? Aha, yes it is. So we're going to use these two, and that means we can factor. So 0 is equal to x is our first term. Our last term sign is negative, so that means the signs are opposite, which we can also we can also figure that out by our sets of factors. 2 has to be positive, 4 has to be negative, so that tells us where those go. And again, we don't need to check whether or not that works because we've already checked this up here. Now we use our zero product property. Remember, which says two products equal to 0 can be separated. And so 0 is equal to x plus 2 and 0 is equal to x minus 4. Now typically we've seen that backwards where it's x plus 2 equal to 0, but we're going to continue it on since we're dealing with a function this way. All we do is solve for x. X is equal to negative 2. X is equal to 4. Now, that is what x is equal to, but that's not what our answer is. Okay? These are x-intercepts. These are zeros. So the zeros are 2, 0 and 4, 0. And I should say, excuse me, negative 2, 0 and 4, 0. Why are they written this way? Because these are ordered pairs. They're coordinate points on a Cartesian plane. And so that's what our answer is for number 11. Now, let's do 12 to take a look at it. So 12 is the f of x equal to x squared plus 6x plus 8. And again, we're going to plug in 0 for f of x. So 0 is equal to x squared plus 6x plus 8. Now, again, we're going to solve this quadratic by using either factoring, taking the root, or quadratic formula. Let's say, again, you didn't understand this process. I know that that's a little bit more involved for some of us than what we're comfortable with. So let's just say we only want to solve these by using the quadratic formula. And that's great. That's fine. So a is equal to 1, b is equal to 6, c is equal to 8. And we're going to plug in those values into the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so x is equal to negative b. B is equal to 6. So a negative b would be negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 8. And then all over 2 times 1. So negative 6 plus or minus the square root. 6 squared is 36. Negative 4 times 1 is negative 4. Negative 4 times 8 is negative 32. 2 times 1 is 2. And then 36 minus 2 is 4. The square root of 4 is 2. So negative 6 plus or minus 2 over 2. And that becomes negative 6 plus 2 over 2 and negative 6 minus 2 over 2. Negative 6 plus 2 is negative 4. Negative 4 over 2 is negative 2. Negative 6 minus 8 is a negative 8. Negative 8 over 2 is negative 4. Negative 2 and negative 4 are our answers for this function here. Okay? And again, those are not how we write our answers. We're asked to find the zeros. We write our answer as ordered pairs, negative 2, 0, negative 4, 0. And that's the solution to number 12 for you right there. We're going to end right here today. That's all for this week. and we will continue with chapter 13 next week in our last week of school.